Our topic for today is adding and subtracting algebraic fractions. Now, you may be a little confused about this term right here, algebraic. That just means that we're using pronumerals as well as numbers. So that's the difference between normal fractions and algebraic fractions. Let's give an example. If we had something like 2/3 and 1/2, those are regular fractions. Algebraic fractions might be something like, let's say, 2 over x and 3, that's a bad example. Let's try x over 2 and y over 3. Okay? Those are algebraic fractions. Now, reminder, what has to happen if I want to add these together? Can I just add them together as they are? No, I can't. Some of you may remember the demented fish. What do we have to do in order to add fractions together? We have to get the lowest common denominator, the same number in both places. How do we do that? The simplest way, though it's not always the best way, but the simplest way is to multiply these together, which gives me 6. Now the demented fish, for those of you who remember that, says 2 times 2 is 4. 2 times 3 is 6, which we put in both places on the bottom, and 3 times 1 is 3. And then we add them together. We add the tops together, the bottom stays the same, 7 over 6. That's how we did fractions. The same is true with algebraic fractions. If I wanted to add these together, I need a common denominator. It's still going to be the bottom times the bottom, 2 times 3. That's the simplest way. So, demented fish, x times 3 is 3x. 3 times 2, that's 6, which I put on the bottom of both fractions. And then 2 times y is 2y. I can add those together. It's going to be 6 on the bottom. Now, we have done adding and subtracting algebraic expressions or algebraic terms. Can we add those together? We can't combine them because they're not the same pronumeral raised to the same power. They are not like terms, but we can still make this a fraction. 3x plus 2y over 6. Okay? That's how that works. So let's use an example. Now we're going to break this down into a couple of pieces. Let's say that we had 3x over 10 and 2y over 15. What would be the lowest common denominator of those two problems, those two fractions? Well, 10 and 15, we could say 150, but I think you know that there's a quicker way, or a simpler way in this case, which is we count by the bigger number. Is 10 going to 15? No. Count by 15. The next one would be 30. Does 10 go to 30? It does. So our lowest common denominator is going to be 30. Now, how do I change my fractions? 10 to 30, what did I do? I multiplied by 3. So I do the same thing on the top. 3x times 3, 9x. Over here, what happened? 15 to 30, I multiplied by 2. So 2y times 2 is 4y. And then I could add or subtract those if I wanted to. Now, let's say that we had this fraction, 2x over 7. And what I want is, instead of 7 on the bottom, I want 21 on the bottom. So I want something that's equal. How did I get from 7 to 21? Think about it. I multiplied by 3. So what do I do up here? I multiply by 3. You get 2x times 3 is 6x. Okay. Now we're going to do a couple of examples that show you how this works in real examples here. Let's say we had 3x over 11 plus 5x over 11. This one's made easy for us by the fact that we already have 11 on the bottom of both fractions. So all we have to do is carry that 11 over here. 3x's plus 5x's gives me 8x's. And I'm done. let's try one just a little harder. 4a over 3 plus 2a over 5. What am I going to do with this? I need the lowest common denominator first. What would that be? Right, 15. Easiest way, 3 times 5 gives me 15. We're going to use our demented fish. 4a times 5. If I have 4 a's and I multiply that by 5, I have 20 a's. 20a. And then 3 times 2a, which gives me 6a. I'll leave the bottom the same. And 6a, 20a and 6a gives me 26a. 6k over 5 minus 3k over 10. Now, exactly the same process. The fact that it's a minus in the middle doesn't change how we do the process. What do we need? Now, we could multiply it together and get 50, but I think you can recognize that the lowest common denominator here is actually 10. Because 5 goes evenly in 10, so we're not going to have to multiply that. All we need to do over here is multiply by 2, top and bottom. 5 times 2 is 10, matches with this. 6k times 2, 12k. Take away, and we're not going to change this at all. 12k's, take away 3k's, I'm left with 9k's. 9k over 10. Okay? One more example, and then we're done. Let's make it minus just to keep it interesting. And we'll make this a 9. Now, again, we need a common denominator. We could multiply 9 and 6 together and get 54. That's going to give us a pretty big number. I think what we want to do is count by the larger number. Does 6 go into 9? No, it doesn't. Let's count by 9s. 9, 18. Does 6 go into 18? It does. So that's going to give us a denominator, lowest common denominator of 18. What did we do here with the bottom? Multiplied by 3. So we're going to multiply the top by 3. Make that easy, 3b. What did we do over here? We multiplied by 2. So we're going to multiply the top by 2. Okay? Then, we want to just say what we get here. We're going to have 18 on the bottom. Now, can we subtract 2a from 3b? No. Why not? Not like terms. Not the same pronumeral raised to the same power, so we can't do that. Well, we just have to write 3b minus 2a, and we're finished. And that is adding and subtracting algebraic fractions.